Hi, ch12. So I got a good question from a student on page 176, number 125. And basically, what this question is asking is if you know what you're going to be titrating in terms of the analyte and the titrant, how do you go about figuring out which indicators is the correct one to go with? So they give you a choice of three different indicators. So I'll do a couple of these. So the first one here, HF and NaOH. So what you want to do is you want to determine weak acid, weak base, strong acid, strong base. Okay, so those are the four. You're trying to determine which two out of the four these are. So NaOH is a strong base, HF is a weak acid. Okay, and so how do you figure that out? Use your table. Okay, so weak acid, strong base. So what you need to remember is strong is always going to dictate over weak in terms of where the endpoint is. Okay, so remember there's three options. Either you have an endpoint at 7, which is what you would have for a complete neutralization, strong acid, strong base, or it's either going to be above 7 or below 7. So here, the strong base and the weak acid, you would expect a pH at the endpoint to be above 7 because the strong base is going to win over the weak acid. Okay, so the pH of the endpoint will be greater than 7, and so of the three choices, we would want to go with phenolphthalein. Okay, so remember pKa is what happens when you take the negative log of the Ka. Right. I'll do one more. Here you got NH3 and HI. So HI is a strong acid, NH3 is a weak base. So again, strong is going to win over weak. So here you're going to expect a pH at the endpoint to be below 7. Okay, less than 7. And so of the three choices, you would go with methyl red. Okay, so that's how you determine which indicator is suitable for titration. So what I want to look at today is buffers. Okay, so these are the questions I'd like you to do at the end here. Okay, so 181, 131 to 140. Okay, so first, a definition of a buffer is it's when you have appreciable amounts of weak acid and its conjugate weak base. So what appreciable amounts basically means is you want to have a lot of the conjugate pair in equal amounts. Okay, so here your conjugate pair would be the acetic acid and the acetate ion. Okay, so that would be part of your buffering system. And so you have equal amounts. So basically when you have equal amounts, what you have here is going to give the system more strength. And what the point of a buffer is so that you can basically maintain a system's pH when there's an introduction of either acid or base into that system. So it's to basically fight off the introduction of acid and base. Now, at some point, a buffering system will break down. So like if you had just endless amounts of acid that you're adding or endless amount of bases that you're adding, it'll exceed the buffering capacity. Okay, and so again, the point of a buffer is to stabilize pH. Okay, so so again, a buffer prevents addition of either acid or base from changing the pH of a solution, and again, it's limited. Okay, so here's a graph, and so there's your buffering region. So you notice over here, it's basically flat at this point. Okay, not entirely flat, but sort of flat. So what this is saying is, if we're starting with some acidic system, and then we start adding base to it, it'll sort of fight it off for this portion where it's kind of flat. The pH will kind of stay steady, but then if we go add too much base, then eventually it'll shoot up. Okay, and so that's why this region here is a buffering region. Okay, so beyond that, it's no longer acting as a buffer. So the way the system works is, again, going back to Le Chatelier's principle. Okay, so let's so you can have different types of buffers. So it depends on what type of pH you're trying to stabilize. So it could be an acidic buffer, or it could be a basic buffer, different levels of buffering systems depending on where the pH is you're trying to stabilize. So here's an example. You've got NH3 and NH4 plus. Okay, so that's your buffering system. So again, the conjugate pair is your buffering system. And the way you set up the buffering system is by having equal amounts of both of these. Okay, and so one of them you start with, it's going to ionize, and then you add more of the salt that would contain NH4 plus to lift up the amounts of NH4 plus present. Okay, so again, the key thing for a buffering system is these two need to be equal, and you want to have appreciable amounts of them. So let's say we add a small amount of HCl. Okay, so what's going to happen is the HCl is going to want to react with the OH minus to produce water. And so if the OH minus is reacting with the HCl, then it's being reduced, right? Because some of it's going off and producing water. So then what the system's going to do is it's going to shift right. And when it shifts right, you'll lose some of the NH3, you'll gain some NH4 plus, and then you'll also gain a bit of the OH minus back. And by getting the OH minus back, that'll restore the pH to whatever it was. Okay, so HCl reacts to OH minus, reduces hydroxide, system shifts right, NH3 drops, and NH4 plus increases. OH minus then restores itself. Okay, so what you're trying to do if you're trying to maintain pH is you want to keep either your hydroxide ion concentration, in this case where it's a base, or your hydronium ion concentration if it's acidic, to stay stable. Okay, sort of stay the same. If we add NaOH for part B, now the hydroxide ion concentration will go up, so that's your stress. Okay, so again, think of stresses when we're talking about Le Chatier. The system's going to shift left, so your NH3 is going to go up, your NH4 is going to go down, and because we're going left, then your hydroxide ion concentration will also drop. And again, that restores it back to what it was. Okay, so hydroxide increases, system shifts left, NH3 increases, and then NH4 plus and OH minus drop. Okay, it's not going to be exactly at what you started with, but again, the idea here is to sort of keep the pH somewhat stable. The next topic we'll look at is pH in buffers, in biological systems, and our blood has a buffering system, and so that is with the introduction of amounts of acid or base, our blood pH level kind of stays at the same. Again, to a certain extent, right? If we add too much, then we exceed the buffering capacity and the buffering system breaks down, right? Which means that it no longer works. So part C, would this be able to neutralize 1.5 moles? So if you look at what you've got a 1 mole system of NH3 and NH4 plus. So again, notice how we have equal amounts of both of these. So 1.5 moles is more than that, right? So that's going to exceed the buffering capacity. And so the answer to this question is going to be no, right? Because there's only 1 mole of ammonium present, because that's what you would use to neutralize the hydroxide, and 1.5 of that. So that's going to exceed the buffering capacity. So when we say you exceed the buffering capacity, what that means is you're not going to be able to maintain the same pH. Okay, so what I want you to be able to do is first off understand what the point of a buffer is. Okay, so what's the buffer trying to do? And then secondly, how do you set up the buffer, whether it be an acidic buffer or a basic buffer? And then explain how it works when there's an introduction of acid or base into the system. Okay, so I'll stop there. So again, do these questions here, 181, numbers 131 to 140, and keep asking questions. Okay, so I'd actually like to see a little bit more questions that I'm getting. I know, especially when there's calculation type questions, I should be getting more questions. Some of these are a little bit on the complicated side. So again, just ask if you don't understand something. Like I said, we will be able to get through the remainder of the course. We'll probably spend, next week will probably be our last week on the acid base unit, and then the week after we'll start the final unit on electrochemistry. Okay, so have a go at those and try to get those done by Monday. And again, let me know which questions you want me to go over. Okay, so again, stay safe, and I'll talk to you again on Monday. Okay, bye now.